class, like a normal Java class, that actually has a normal main method. What this is actually doing behind the scenes is it's calling out and it's doing the Ruby code underneath. So we can run this. I'll throw JRuby's jar in here. Ruby main. Actually, need.2. All right. And I'll complain because I didn't pass the arguments. Okay, so there. Hello. There. Okay. So now this is actually a normal Java class with a normal main method that's actually calling Ruby code. And that's fairly simple to do. What's actually a little bit more exciting is if we look at, let's look at a metaprogramming example. Okay? So what we actually have here, I'll make that 2 lines so it's easier to read. What we actually have here is we're iterating over all of the primitive Java types, byte, character, short, etc. For each one, we are defining a new method for it. So programmatically, metaprogramming a new method into this class at runtime, and then defining a signature for it. So mapping whatever that Java type is and just having it return that type. This is something that you can't actually even do in any of the other dynamic languages. Metaprogram a class and have it look like a normal Java class. But it works here because what happens at compile time is that it's actually loading that file. So in this case, it'll be metaprogramming and lib metaprogramming or examples metaprogramming is what we want. All right. So that'll load up that file. It'll do all the metaprogrammed logic at load time, at runtime, and then what we get out of it is in the previous case, we get a normal Java class, and there's all the methods. And the even more cool thing about this is that unlike, well, at least I don't think Ruby can do this. Unlike some of the other JVM dynamic languages, if you have more runtime code that redefines these at runtime, or if you have method missing, or if you have other magical Ruby metaprogramming changes that you make, they'll actually be reflected here. So when you call the Java version of that method, it will reflect your metaprogram changes that happen at runtime, because it's actually doing the Ruby call. So that's pretty cool. The final one I wanted to show, it's often been said that JRuby would never be able to support annotations because we don't have normal Java types, we don't have normal Java type signatures, and that's patently false. So let's take a look at an annotation version. So I have 2 tests here in my little test something. The first one is testing to make sure that JRuby rocks. Okay, and it'll fail unless JRuby rocks. And the second one is testing that JRuby will never support annotations, and it will fail if it does support annotations. So we want to see if this actually is true. What we actually do down here, it's very simple. Just like we define the signatures, we define some annotations. So for the test JRuby rocks method, we want to attach a JUnit test annotation to it. Same thing for this other one. For the never support annotations, we just attach a test thing to it. All right, 5 minutes. And so if we generate this class, I think JRuby-JS. I'll pull in JUnit here. Okay, so we'll run the compiler with JUnit available, and we want to do test something, examples, annotations. Okay. So we've run that. Now, does anybody remember what the JUnit test runner is? We'll actually just look at it in a very super secret way. Test something. Okay, so here's all the nasty output. What we actually have here, obviously, if you look at this, you can see it has attached the JUnit test annotation. Everyone knows what that is, right? So I'm not going to run it because we're a little short on time, but you can see that it's obvious. We can do the annotation stuff. It's just a simple simple matter of adding it, putting it into compiled output, and you can have normal tests and normal annotated code. And so JPA, JAX-RS, and all the other APIs that expect annotations can work just fine with JRuby. We're going to work on improving this over the summer to make it a little bit easier. All right. So the final thing I wanted to mention, I don't know if anybody saw the DaVinci machine talk earlier. There will be another one later this week at Java 1. The DaVinci machine is an effort to improve the JVM for various languages, dynamic and otherwise, but especially dynamic languages. And the way that we're really helping here is we're the first ones that have done dynamic invocation using the DaVinci machine's JVM editions. We are providing a lot of feedback. I actually made a patch for the JVM. How many people here have ever submitted a patch to OpenJDK? That's right. All right, I'm really proud of that one. So I'm really excited. Java 7 most likely will have this stuff. And then the last two things, kind of, was it worth it? Well, JRuby is an alternative to Ruby now. We're really happy to say that we have a production quality Ruby implementation on the JVM that is one of the best Ruby implementations available. Never has that been done, that this can actually be a real, true, viable alternative to the C implementation. We got lots of production users, there's governments, telecom, finance, all that stuff. Sun's got stuff, Oracle's got stuff. There's announcements coming out this week of more apps that are coming up on JRuby. So, and of course the small scale Ruby guys, they're using JRuby too. This doesn't have to just be big enterprises that are running this. And we've met a lot of people, we've had a lot of fun, done a lot of traveling. And so what's the point for all of you? Well, the point is that nothing is impossible. You can do these things on the JVM. You can call C libraries. You can implement your own string if you really need to. And in doing that, just as JRuby has, you can help expand the platform too. Future directions for the JVM, future directions for Java. You can show the future and change the future of where this platform is going to go. Because this is our platform. We have to make this succeed. And this is the way to do it. Just don't let anybody tell you that any of this stuff is impossible, because you can do it. It just takes a little bit more effort, a little bit of thinking about it. And open source conquers all. We love our contributors, and thank goodness we have people like you and like others that can contribute to our project. So there's some links for other information, and we got a couple minutes for questions. Yeah, right over here is fine.
Do you take pride when other Ruby implementations have come out and they've brouhaha about their speed, and yet their compatibility leaves a lot to be desired? Is there any effort being put forth by the Ruby community to have compatibility scale, not just speed?
Yes, well, partially because I whine about it so much. There are now efforts to include, along with benchmark results, some sort of measure of compatibility, probably using the partial Ruby spec suite that has been developed, just to kind of show that, yes, it's easy to get a broken implementation to run fast early on, but varying levels of brokenness aren't particularly useful, no matter how fast it is. So there are efforts to do that, and we're seeing more and more that people are kind of taking performance numbers with a grain of salt and measuring it against how compatible and usable it actually is. So I think we have time for one more. So.
Okay, well, congratulations on the project.
Thank you.
I do have one sort of concern or worry. You're very excited about being able to call C libraries, but of course that may not work on every implementation of the JVM. And in particular, thinking of Google App Engine, where that kind of calling is completely ruled out by the framework. So my worry is really, how do you sort of encourage developers not to overuse that facility, because they would lock themselves out of other possible platforms?
Right. Well, the primary focus of having the FFI capabilities and the ability to call C libraries is basically a stopgap measure. If somebody really needs Nokogiri or a libFFI wrapper to get their application up and running, us just saying you're out of luck means that they will probably never move to JRuby. They will, if they have the opportunity to call it through FFI and use one of these libraries, then they can at least bootstrap on JRuby, see some of the benefits, and then as we get real ports, real Java-based ports of those libraries, they're still on the platform and they can move to those as soon as they're ready. It's kind of just a way to reach out to the Ruby community, which is so bound into the C library world at the moment. We don't intend that it's going to be what people do for typical production applications generally. All right, I think that sound means that I have lots of time left.